to start off D, again, let's just identify what you want our U to be and what we want our DU to be. Well, looking at this problem, I'm just going to go to the part that has the power as possibly being our U. So the 1 minus sine 2t, let's see if that would work. So U is equal to 1 minus sine of 2t, and that would make du to be, well, the derivative of sine is cosine, so I'm going to keep the negative out front, but it'll be cosine of 2t times the derivative of that angle, which is 2, and then dt. Or we can write du as being negative 2 cosine of 2t and then dt, where that's my angle right there. Okay, so going to the main function, I've got the 1 minus sine 2t, that's u. I've got cosine 2t dt, all I need is a negative 2 in here, so let's counterbalance it with a negative 1/2 out front. So right now we're looking at negative 1/2 integral, I'm going to get my new bounds here in just a second, of, looks like u to the 3/2 du. Okay, let's get those new bounds so we can get going with this problem, get an answer. Well, let's see. First of all, t is equal to pi over 4. So what happens when t equals pi over 4? Well, u is going to equal 1 minus the sine of 2 times pi over 4, which would be pi over 2. Well, sine of pi over 2 is 1, so 1 minus 1 is 0. So when t was pi over 4, we're going to go to 0. Now when t is equal to 0, we have u to be 1 minus the sine of 2 times 0, which is 0, and the sine of 0 is 0, so u is equal to 1. Okay, so let's keep working with this integral. So negative 1/2, and the integral of u to the 3/2 would be u to the 5/2 over 5/2, evaluated from 1 up to 0. So kind of manipulating this, bringing this fraction out front and flipping it, looks like that would be a negative 1/5, u to the 5/2, evaluated from 1 to 0. Let's plug in our upper bound. So 0 to the 5/2 minus 1 to the 5/2. And wrapping this up, 0 to the 5/2 is 0, 1 to the 5/2 is just 1, so basically a negative 1/5 times a negative 1 will give us a final answer of just 1/5. Okay, so that wrapped up all the examples or all the parts for part 1, so now we're going to go back up and go back to actually the first page. So we're going to go to now example 2, which is the page prior to this. Starting here with part A, we want to find the total area for the following graphs. Okay, so this is where we're going to be practicing going from a curve, one curve to another curve. And our rules basically tell us that if I want to integrate specifically, so we're taking the integral from, it looks like 0 to pi, that's where the shaded region is. So if we're going to take the integral from 0 to pi, what they tell us, it's the upper curve, which is y equals 1, minus the lower curve, which is y equals cosine squared x. And then all of that dx. Alright, so now when I go to take the integral, first thing I noticed real quick is I could do is trig substitution technically, because I could either isolate this as going, okay, the integral from 0 to pi of 1 minus the integral of 0 to pi of cosine squared, but I realized that I have that wonderful trig substitution where this is the exact same thing as the integral from 0 to pi of 1 minus cosine squared, which is sine squared x dx. Okay? And because I don't know how to integrate a sine squared, I know how to integrate a sine, but not a sine squared, we're going to do one other trig substitution and realize that that's the 0 to pi. Again, those are all on that back flap of the book if you need to go back over them. But it's 1 minus cosine of 2x over 2 dx. Or just splitting it up to two terms. It's 1/2 minus 1/2 cosine of 2x dx. And what this does is it writes it all in terms where I can definitely take the integral of 1/2, and I can definitely take the integral of the next part. Okay, so now that we've gotten all that, let's come over here and actually do the integral. So the integral of 1/2 with respect to dx would just be x over 2, evaluated from 0 up to pi. Okay, and I'm going to do minus 1/2, and the integral of cosine 2x is 1/2 sine 2x, evaluated from 0 to pi. Just remember that formula is 1 over k times sine of kx. All right, so let's plug the information in. When I plug in the top bound, it's going to be pi over 2 minus 0 for the first part, and then say minus 1/4, and then here it's going to be the sine of 2 pi minus the sine of 0. Well, the sine of 2 pi is 0, the sine of 0 is 0, so it looks like everything here on the right is going to go away, and my answer is just pi over 2. All right, let's go to part B. Again, I have two curves here. I've got y equals x squared, and then if I rewrite this one, it's going to be y is equal to negative x plus 2 or 2 minus x. Let's just go 2 minus x. How about that? Now, in order to find then the true area under the whole curve, we kind of almost have to break this down to two parts, because again, one part has y equals x squared as the upper portion, and the next part has just this y equals 2 minus x. So what we're going to do is divide this up into two equal pieces, where both times this line down here, which is y equals 0, is the lower end. So we're going to divide it going from the full area is going to equal from 0 to 1 of the upper bound, which is y equals x squared, minus the lower bound, which is 0. So it's y equals x squared and y equals 0, and then dx. And then I'm going to add on the next part of the area, which is going to go from 1 to 2, the upper one, which is y equals 2 minus x, minus the lower one, which is 0, dx. Okay? So taking the integration, this is going to equal 1/3 x cubed. Obviously 0 is not going to come into play, just evaluate it from 0 to 1. And the next one, we got to take the integral of 2, which will be this 2x, and the integral of x is 1/2 x squared, and that's going to be evaluated from 1 up to 2. Okay, so let's plug in our bounds. We have 1/3. When I plug in the upper one, I'll get 1 cubed minus 0 cubed, plus, okay, so here, let's say I'll put the 2 out front, and then we have the upper one, so 2 minus the lower one, minus 1/2 the upper one, so 2 squared, minus the lower one, 1 squared. Okay, let's get a final answer. 1/3 of 1 is 1/3. 2 plus 2, why do I have an x in there? I need to fix that up. I forgot to put that lower bound in there. It should be 2 minus 1 right there. Okay, so it's like, if you're plugging in a bound, you should be getting a definite answer here. So 2 minus 1 is 2. And then minus 1/2 times 4 minus 1 is 3. And then combine this last little bit, we'll get a final answer of 5/6. So there's the area. And you just kind of need to watch out for that, especially when it's divided into two groups, when you kind of need to focus on one and then the other one. Okay, so the last one for this group, part C. Okay, this looks like it's going to be quite the hefty problem, but definitely something we can do. Okay, notice how we've got two curves going on. We've got this guy coming up and swinging around like that, and that's that y equals 2x cubed minus x squared plus minus 5x. And then we have another one coming just like that, and that's that y equals negative x cubed plus 3x. Okay, so every time we do this, we need to look at upper bound, or the upper curve to the lower curve. And hopefully you guys can see we're actually going to have to divide it into two equal pieces, because one time the blue line's on top, the next time the purple line's on top. So we definitely have to divide it up into two pieces. Okay, so the coordinates there are likely going to help us out here. We're going to start at, so total area is going to be integral from -2, it looks like it's going to go up to 0, where those two lines meet. It's going to be the upper one, so 2x cubed minus x squared minus 5x minus the lower one. I'm going to put it behind a minus sign, so I want to make sure I'll put it in parentheses. Okay, so that's all the first half, plus, now the integral looks like 0, and we're going to finish up at 2 for the next coordinate. Now this time, the upper one is the negative x cubed plus 3x, and we need to subtract off the lower one, which is this time the blue line, the 2x cubed minus x squared minus 5x. And then all of that dx. Okay, so obviously it would probably be very smart of us to go through and combine like terms and see what we've got. So 2x cubed plus another x cubed would be 3x cubed. And this is the negative 2 to 0 one. Then we have the minus x squared and negative 5x minus 3x, so negative 8x. All of that dx. Okay, plus the integral from 0 to 2 of negative x cubed, so negative 3x cubed minus x squared, and plus 8x dx. Okay, and just looking this over just real quick, make sure I've got everything in there. It looks like this one needs to be a plus, because I got negative, negative, now be plus. Alright, fingers crossed. Let's hope we got this all right, because it would be so nice. I would hate to have to go back and go, okay, missed a sign change, but you know, that's, of course, that's always going to have to happen. Alright, we're going to integrate down the line. So, starting out, the integral of 3x cubed, that'll eventually be 3 times x to the 4th over 4, minus, I'm going to wait and put all my bounds here in just a second, but minus x cubed over 3, and then minus 8, and that'll be an x squared over 2. Okay, so each of these is going to be evaluated from negative 2 to 0. Plus, okay, we have negative 3, and we're going to have x to the 4th over 4, plus x cubed over 3, and then plus 8 times x squared over 2, evaluated from 0 to 2. Let me see if I can clean this up. So 3/4 x to the 4th minus 1/3 x cubed minus 4x squared. That's going to be evaluated from negative 2 to 0. And then plus, it's like negative 3/4 x to the 4th plus 1/3 x cubed plus 4x squared, evaluated from 0 to 2. Okay, so each one of these I'm going to plug in zeros for upper bound, then go in and plug and subtract negative 2 plugged in. Over here on the right, I'm going to plug 2 in and then subtract 0 plugged in. Okay, so I'm going to kind of go just down a little bit. We're going to go to the next section so y'all can kind of see me do this a little bit. Okay, when I plug in 0, hopefully the upper bound, y'all can all see it's just going to give me a big fat 0. Because all the x values are going to go away. Now I've got to go minus my lower bound plugged in. Okay, so 3/4 times x to the negative 2 minus 1/3 x, I'm sorry, not x anymore, but negative 2 cubed. Yeah, it would help if I substituted it correctly. Oh my gosh. We can have major brain fart today. Okay, 3/4 negative 2 to the 4th minus 1/3 times negative 2 cubed minus 4 times negative 2 squared. Woohoo, got through that one. Yay. All right, now plus, we're going to come down here, negative 3/4, putting my upper one, so 2 to the 4th plus 1/3 times 2 cubed plus 4 times 2 squared, all of that, and then minus my lower bound plugged in, which is going to be all of a bunch of zeros. Alright, we are almost there. If you want to pause it real quick, see what you can get, let's come back and compare answers. That way we can just say, hey, here's the answer, box it up, call it done. Okay, when doing all of this, looks like we add up to a total area of 32. Okay, now I might have gotten off a little bit there in size. I don't know. I'm keeping my fingers crossed. Hope that's all right. So y'all please forgive me if something was wrong. But fingers crossed. I think we got a good, nice, pretty answer as an answer. So let's move on.